Hi, this is Dr. John Bergdorf. This video is a companion video to the video listed right before it in your assignment entitled Adding and Subtracting Fractions Lesson. In that video, we talked about how to add and subtract fractions, particularly if the denominators were different. And we found out that in that case, you first need to find a common denominator. And the best denominator to use is the least common multiple of the denominators. We also found out that finding the least common multiple involves 4 steps. First, you factor both of your numbers into prime factors. Then you list one time every prime number that occurs in either factorization. Then you raise each factor to the highest power to which it is raised in either factorization. Pick the highest exponent. And then finally you multiply all these factors. If you've not had a chance to look at the other video, please stop this video and look at that one now, because that gives you a couple of nice examples. In this video, I want you to have your turn. So here's what we are going to do. I would like you to add these 2 fractions using the process that we discussed. Now, here's what you need to do. As soon as I say now, put your video on pause, get a piece of paper, try this problem on pencil and paper like we did on the other video. When you are done, restart the video and I will work it with you and we'll see if we come up with the same answer. So I hope you're ready. Turn off or stop the video now. Okay, you're back. Hopefully you've had a chance to add the 5 over 56 plus the 17 over 84. Let's work the problem together and let's see if we come up with the same thing. First of all, we notice that the denominators are not the same. We're going to have to find a common denominator, and so we're going to need to figure out what is the least common multiple of 56 and 84. We will need to factor both of those numbers, so we'll create a factor tree. 56, for example, factors as 7 times 8. 7 is a prime number, so you don't have to do anything else with that. 8 is 2 times 4, but the 4 factors again as 2 times 2. So 56 is 2 to the 3rd times 7, taking all the leaves at the end of the branches of the tree. 84. Let's factor that one too. A little bit harder to see this one. I bet that took you a little bit longer. But one way to factor it is 7 times 12. 12 is 3 times 4. And 4 is 2 times 2. Looking at the leaves at the ends of the branches of the tree, 84 is 2 squared times 3 times 7. Now, to get the least common multiple, you want to list every factor, every prime number that you see in either of these factorizations. I see some 2s, some 3s, and some 7s. Raise each of those prime numbers to the highest exponent to which it is raised in either factorization. So if I look at the 2's, the highest exponent on the 2 is a 3. 3 is simply raised to the first power, and 7 is raised to the first power. So the only exponent we need is 2 to the 3rd. 2 to the 3rd times 3 times 7. Multiply those together. And that might have taken a minute or two as well, but you should have come up with a common denominator of 100, or common multiple of 168. That should become the common denominator that we want between these 2 fractions. Let's make another column and see how to get that. So I've got my 5 over 56. I would like the denominator to be 168. So I ask myself, what do I multiply by 56 to get 168? I can see that most easily if I look at the 56 and the 168 in factored form and ask myself what's missing. The 168 has a 2 cubed and a 7 like the 56 does, but it also has a 3. So that tells me that I need to multiply by a 3, and whatever I multiply in the denominator, I also need to multiply in the numerator. Now, I also have 17 over 84, and I need to look at the 84 and see what I need to multiply 84 by to get 168. And looking at that factorization and comparing them, I see that the 168 has an extra 2 that the 84 doesn't have. So I think I need to multiply by 2. Multiply the numerator by 2 and the denominator by 2. 5 times 3 is 15. 56 times 3 really is 168. 17 times 2 is 34. And 84 times 2 really is 168. Now I've got the same denominator. Once two fractions have the same denominator, then what you do is you copy the denominator and you add or subtract, if that's what you're doing, the numerators. Let's move to a fresh slide. Here's just a repeat of the example we were looking at, and where we are right now is that we've determined that what we have is 15 over 168 plus 34 over 168. Let's look back and make sure that we agree. Yep. Because the denominators are the same, we copy that, copy the 168. Well, there we go. Pen wanted to quit on me for some reason. Try again. And the 34 plus the 15 would give me a 49. And I need to ask myself, as always, will that fraction simplify any? Well, what might help you there, if we look back at how the 168 was factored again, I'll just kind of rewrite this over here. The 168, you might remember, was 2 to the third times 3 times 7. So if there is any factor in common between the denominator and the numerator, it would have to involve one of these factors. That might be your clue right there. If you look at the 49, that's a famous number. 49 is 7 times 7. And if I look at my 168 in factored form, I see that 7 divided by 7 is 1. One of those factors will divide out. And then I just look at what's left. The numerator will be 7. And then 8 times 3, 2 to the third is 8, times 3 is 24. If all is said and done correctly, you get 7 over 24. Is that what you got? I hope so. If you did get that, pat yourself on the back. If you didn't, take a look back through your work and compare it with what I've done and see if you can find your mistake. And next time, it'll go much better. Now, before we leave the adding and subtracting of fractions completely alone, I want to show you a slide that I skipped over for lack of time in the previous video. It's a warning. Many times in different classes, instructors show you a different technique for adding fractions that involves something called cross-multiplying. It's a little trick that actually happens to work if the fractions are fairly simple, but you really, really don't want to do that. I'm going to work the exact same problem we just did and show you what the cross-multiplication method is in case you're familiar with it, just so I can convince you to not do it ever again. Now, if you would rather not be confused by looking at something that isn't going to work anyway, just go la 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 la, cover your ears and turn off the video, and you don't have to watch any farther. But let me show you how some people teach the adding of these exact same two fractions, 5 over 56 plus 17 over 84. Now the key word there is cross-multiplying. Here's the way this works. You take the 5 from the numerator, from the first numerator, and you multiply it by the 84 from the second denominator. 5 times 84. That's a time symbol. Then you form a little cross and you multiply the denominator of the first fraction by the numerator of the second fraction, and you add that together. So 5 times 84, again, that's a multiplication symbol, in case that got a little bit ugly. In the denominator, you multiply the two denominators. So 5 times 84, 56 times 17, multiplying across, and then multiply the two denominators together. Then you just do all of that arithmetic, and here's what you get. 1,372 over 4,704. Oh my goodness, what a mess. And we know from having worked this example already that that's going to simplify. But is that going to be hard to simplify? What you would have to notice is that the 132 happens to factor as 196 times 7, and the denominator factors as 196 times 24. Does that sound like fun? But then the idea is you would divide out the common factor of a 196, and you would finally get your 7 over 24. Moral of the story, cross-multiplying, although it might at first look like it was a clever idea, is not something you really want to do. And in college algebra, when you focus on adding rational expressions where there are variables included in the fractions, it gets even more crazy. So I hope this helps and gives you a good, strong foundation on working with fractions, particularly how to add and subtract.